So basically today we are going to start with a new chapter, chapter 4, extractive metallurgy. Okay. Those actually from industrial chemistry, you will notice there's one experiment in extractive metallurgy in your KIT 357, industrial practicals. I think experiment 6, still with me, extractions of metals. Okay, this experiment actually we conduct using a copper coupons, and then you will put I think some chemicals which later on it will leach the copper, and you will measure using AAS, and you will measure the mass loss, right? So the subject itself, extractive metallurgy, is kind of interesting because it is a combination between chemistry and also materials. Yes, so far to my knowledge, materials engineering students learn about extractive metallurgy quite a lot. Okay, and there's a few processes that you guys need to understand in extractive metallurgy. Okay, so the name of this, words, the keywords, metallurgy. Anyone knows what does it mean by metallurgy? Okay, metallurgy is actually a study of metal. You study the behavior, the properties of metals. Okay, and extractive metallurgy means that how you are going to obtain metals. Okay, the extractions of metals from the raw materials. So the raw materials that we are talking here is that ore. Okay, in Malay we call it as bijih lah, bijih besi, bijih logam, ore. Okay, and for metal scrap. So that is why you see these days people recycle metals. In fact, in the recycle industry, metals is being put as one of the materials that can be recycled, right? So things that you are going to address in this chapter, of course, the first one is basically mining, how we can actually obtain, how we can get the ores or the source material for metals. Okay, and then the types of ore in metallurgy extraction. Okay, you have different types of ores, starting from oxide ores, halide ores, and whatnot. Alternative raw materials. Okay, what would be the alternative raw materials apart from ores? Of course, as I said just now, you can use also metal scrap as one of your raw materials. And finally, the type of metal extraction. So the type of metal extraction, it can be divided into 3. Okay, so the first one is known as pyrometallurgy, second one hydrometallurgy, and third one electrometallurgy. All this actually we are going to study more details in this chapter. As I said earlier, metallurgy is a domain of material science and engineering that studies the physical and chemical behavior of metallic elements, their intermetallic compounds, and their mixture, which are called alloys. Remember, I think in KIT 257, materials chemistry, you learn about alloys. What does it mean by alloys? Alloys is actually a compound or a mixture of at least 2 metal elements together, okay, to produce a new metal. Okay, metallurgy is also the technology of metals, the way in which science is applied to the production of metals and the engineering of metals component for usage in products for consumers and manufacturers. Okay, so in metallurgy also we look on the technology, what types of extraction methods, what kinds of precaution, what kinds of facilities that we need to consider in order to extract the metals. Okay, I believe this one you have learned it during your high school. Part of my favorite subjects during high school is geography. So if you look, I think the distribution of minerals in Malaysia, you will see that we are blessed to have, I think, plenty minerals resources in Malaysia. In fact, I think you can notice every state have its own special minerals. So these minerals is actually an important compound or an important source for your material, like metals, for example. Okay, so you can see like uh, apa tu? In Selangor or in Perak, especially in Perak, you have apa tu? You have tin, you have tin mining in Perak. You can also have wolfram. You have also gold, gold Lubuk Mandi. I'm not sure Lubuk Mandi. I think if I look here, it's kat mana ni? Terengganu kot. Okay, Lubuk Mandi. I'm not sure whether it's still there or not. But in some state, like Raup, they have emas. They have gold. Gold mining is still actively, I think, done over there. And I think in other states, like in Johor, for example, my hometown, we have like bauxite. We do also have, I think, charcoal, and other things like probably uh, tin or granite. So granite, you can notice near to the highway, dekat mana tu Jelapang, to Jelapang, you see there's like I think milestone, sorry, milestone, limestone, limestone. I think hills, and this is actually very rich with lime that is used for tiles, for the production of tiles, cement, ceramics, and whatsoever. Okay, but unfortunately, I didn't see anything in Penang. So those who coming from Penang, maybe we are not sure what kinds of mineral that we have here. Maybe jeruk pali je kot. Guess so lah. Alright. And other states like in Sabah or Sarawak, even Sabah and Sarawak, they are blessed to have a lot of materials like copper, copper in Mamut. There's one mining site near Mamut, which even until now, after the copper mining, it creates another problem because the lake is actually having a high content of copper, and it actually harmful to the environment because the trees or the marine life or wildlife that consume the water will be exposed to heavy metals. Other states like Sarawak have lots of gold, and also not only like minerals, they also have lots of, crude oils. And, I think mine in this state. Right. So extractive metallurgy, as I mentioned earlier, is the chemical process that separates metal from its mineral. So in order to obtain pure metals like aluminium, okay, so you know aluminium, where does this aluminium comes from? Anyone know? Siapa tahu? Kat mana? What will be the source of aluminium? Anyone from Kuantan tak here? Does anyone coming from Kuantan or from Pahang? Okay, you'll notice that part of the issues related on Linus, Linus ke Linus, okay, is that they actually produce like rare earth, I think, element, and in Kuantan also near, I think, Cendrawasih area or whatsoever, they actually mine bauxite. You see the bauxite color is basically like reddish brown, okay, in color. Bauxite is actually very rich with alumina and also iron oxide. So bauxite is basically the raw material to produce aluminium. Okay, and refining is actually the process that purify the metal for the usage. All right, so we have different types of ores, different types of minerals. Okay, so basically you will learn about types of mineral in this chapter and also next chapter on ceramics. So there's a few ores that you need to know. The first one is the most common one, the oxide ores. For example, you have ferric oxide. Okay, you can also have magnetite, Fe3O4. Apart from iron, other heavy metals which are produced from oxide ores are manganese. You can also have manganese oxide. You can also have chromium oxide, titanium or titanium oxide, tungsten, uranium, and also tin. Okay, I think in Malaysia we don't have uranium oxide. In some countries like in Pakistan, they have uranium. Okay, and we do also have other types of ores which is known as sulfide ores. Sulfide ore, it means that ores that contain sulfide or S, contain S. For example, copper ore normally exists as sulfide. Okay, you can have chalcopyrite. Okay, chalcopyrite. You can have sphalerite, galena, PBS, pyrite, okay, FeS2, and other types of sulfide ores from different types of heavy metals. And finally, we can also have halide ores. So halide ores, it means that minerals that contains halogen. Okay, the most common one is, of course, sodium chloride. Okay, NaCl. Okay, rock salts of sodium, magnesium chloride in seawater, and whatsoever. Commercial production of metals, normally we have to consider a few things in order to produce metals. The first one is the availability of the ore deposits. So if you want to produce iron, for example, you know that the availability of iron ore will be easy to find in that particular area. Concentration of metal in the ore is also important. If you have a less amount, then it is not worth to do the mining and also the extraction methods. If the concentration or the amount is huge, then we can actually consider this as part of the production. The availability of technology and extraction of refining of that metal is also important. Okay. Physical and chemical properties of the metals, whether it requires heating, it requires the use of special chemicals for leaching and others, this more or less important. And finally, the market demand of that metal. If you don't have a demand, then you know that it is not really worth to make that kind of industry. So at the end, what we should look is the economy of the process. It should be readily available, easily produced, and available at low processing costs with desirable properties. Right. So this some interesting facts just to share with you guys. Okay. Mm, I think long time ago, people are advanced, even in the I think copper age. We have ice age, we have copper age, bronze age, we have iron age, and others. Okay, so probably this a picture to show your ancestor lah. Maybe ini gambar atuk siapa ni kot. Kot atuk Liana ke apa ke. Okay, that actually have the technology, okay, to produce metals. You will see in ancient world, they produce spear, they produce blade, they produce knife, axe, or whatsoever using the technology. So they actually know how to produce this material from experimental I think experience. Probably they have the minerals and thought of that as a source of food, so they just put it in on fire, and finally, what happened is the metals or the minerals will become molten, and after that, they put in a mold, and it happens that it become a structure. Okay. So the first metal produced was copper and bronze, produced by smelting copper and tin ores in charcoal fire. What's the difference between copper and bronze? Bronze actually means that it is a copper alloy. It contains some trace amount of carbon, okay, as compared to copper. So those days, in order to facilitate the smelting process is actually the burning process of minerals. Okay, they will put like on fire. In the same time, they will mix it with coal, charcoal. Okay, the reason why is because to facilitate the burning process, but at the same time, the carbon will be integrated into the metals. The world production of steel, okay, yearly is around 1,400 megatons. Okay, aluminium 40 megatons. Okay, copper 70 megatons, lead around 8 megatons, and as follows. Steel is highly consumed material, and its per capita consumption is the index of economic prosperity of any nation. Okay, so of course, if you have like an industry, steel making industry in your country, then this will actually will give a reflection on your GDP or your GMP. Okay, the growth rate of metal production was highest during 1950s and 1970s. This is actually the industrial era. I mean, countries or people start to, look for advancement in technology. They produce car, they produce machine. Then the use of metals is keep increasing. In fact, it can be even before that, in 30s and 1920s and 1940s, because in this era you have like World War One and World War Two. During this time, there's a lot of I think tanks, airplane, and ships. Okay, were produced. Then the consumption of metal is also highest at that time. China exhibited higher growth rate in the last 10 years. Okay, so China have the highest growth rate of metal production. Okay, especially I think if you notice from year 2002, they produce around 182 megatons of iron, okay, or metals, and in 2011 it have been increased like 7 times or 6 times more, to become 700 megatons. Okay, all right. So the production of metals can be categorized into three major parts. The first one is actually from mining. Second one is metal concentration, and finally metal extraction. So we are going to look this process one by one. The first one is known as mining. Okay, so for mining, we have five main types of mining. The first one is open cast mining. In Malay, we call it lombong dedah. If you still remember your geography, so this part of the methods. Open cast mining. The second one is underground mining. Okay, underground, you make a tunnel. Okay, you start to dig a hole, you dig a tunnel. Okay, to extract the metals from the underground. You can also have open pit mining. Okay, so open pit is more or less almost the same as open cast, except that for this type of mining, it will form a pit. This also you can see quite a lot in Malaysia. The fourth one is dredging. Okay, using a dredging machine, kapal korek. Okay, you can see this a lot in Perak or Selangor, where the tin was mined using dredging machine. And finally, solution mining. This is an old-fashioned mining way. You just use a solution, because some of the minerals will leach or will goes into the streams. Okay, and they just like use like a special tool. Macam dulang tu. Okay, mendulang. You use like a dulang or whatsoever to concentrate the minerals, and finally you can get the minerals. The first one, open cast mining. Okay, so open cast mining is actually you can see it use excavator or a machine to actually remove the layer of a overburden. Okay, and finally using the same machine to recover the ore. So various types of earth-moving machines are used to remove the topsoil or the overburden. Okay, because the topsoil normally doesn't contain any minerals. It's just containing, I think, soil for agriculture or others. Bulldozer are the most common one. Okay, open cast mining usually very economic. Sometimes explosive may be used if the mineral is in rock. I remember, I think during those days, my village is near to a quarry. So every day we will hear explosion because they just want to explode the stone, and then after the stones have been like crushed into a small size, then they just like transport it using a bulldozer or excavator, and after that sent to a quarry. Underground mining is also another method. I guess in Malaysia, I'm not sure whether we have underground mining, but in Sungai Lembing, maybe Sungai Lembing is near Pahang. You will notice that there's a tunnel that is used for mining. Okay, of course, for this kind of mining, the tunnel will be produced. Okay, or underground hole will be produced. The mine consists of one or more shafts with a series of underground development. The first rock is blasted with explosives and then taken to the surface. And the underground mining is the most expensive type of mining. And normally people do this kind of mining if the precious metal or precious mineral is observed, like gold, or I think minerals like ruby, sapphire, other precious minerals, then it's worth to do underground mining. Otherwise, if it is just coal, charcoal or what, then I think it's not worth. Open pit mining is another technique, almost the same if you see, I mean, with open cast mining, okay, where in this method, the rock face is drilled and then blasted. The ore-based rock is loaded and onto the dump truck for transport for the concentration. Okay, for the concentrating process. So you will see that over here, it forms like a pit. Perhaps, I think these methods like forming a contour is also used in agriculture. Okay, so you see for this type of mining that people will use a lot. So sometimes you will notice after this mine is no longer being used, it will be filled with water. Okay, that is what people say. Jangan mandi dekat lombong. And that's the reason, because if you know, the leftover of mining site, once it filled with water, the pool will be too deep, maybe a few kilometers deep. Then you will see that, of course, maybe the color is quite attractive because it contains a heavy metal that leach out into the water. And you thought of maybe the depth is just a swallow pool or what, but eventually it's too deep. You can imagine, like this one, if it is filled with water, dia akan jadi macam Sunway Lagoon lah. Okay, or I don't know, maybe if you kat mana tu dekat Selangor, there's one place which eventually become a shopping mall. Mana I forgot the name. That was a previous or ex mining site that later on it has been filled with water and become a pool and become like a resort or something like that. Okay, but of course, if you want to swim here, it will be dangerous, too much dangerous. Right. So dragging is also another method. This one actually it use like a dredging ship. Okay, so it has a dragger. Okay, so this dragger actually will like dig or recover the minerals or any deposits on the ground, and then it will be later on processed. So usually some overburden must be removed before the layer of ore can be isolate. The ore layer is then stripped, okay, and brought on board with a dragger where it is concentrated, and then the waste mineral is then dumped overboard. Okay, so the dump sample normally is just having soil, sand, or others. Then it will be dumped in the same area again. So that is why I think if you notice for dragging method, normally it will have some effect on the quality of the water because it will become like too cloudy, jadi macam keruh, cloudy water. Even you can see over here is like chocolate in color because you actually do the dredging, and the waste, and the sediment is later disposed at the same area. And finally, we have solution mining. Okay, solution mining, actually they use water, okay, as one of the medium as a mobile phase to remove the mineral. So it is still being drilled underground, and water will be pumped in. The reason why is because water will eventually leach the metals, and the solution will be removed out. Okay. First, a hole are drilled down into the layer containing the substance to be mined. The two pipes are used. Water is pumped down one, and while the other solution is forced up to the other pipes. So you have like one pipe, another one is like a straw to suck the solutions after the mining. Okay. So far, is there any question for mining? Ada soalan? Ada apa-apa nak tanya? First few methods. Okay. So we are moving on to the next step, which is known as ore concentration. So once you have recovered the ore, it is important to concentrate them because, of course, the raw materials that you isolate, it may contain a lot of residue, solid residue, that it is not an interest. Okay, so you need to do a so-called ore concentration, or sometimes people call it as ore dressing. The aim is actually to increase the amount of metal in each ton of ore. The ore is crushed, then ground and concentrated with the following methods. There's a few methods that you can use depending on the budget and depending on the types of ore that you will use. The first one is known as gravity concentration. Second one, flotation, and finally you have magnetic separation and amalgamation. Right. So before we go one by one, you need to understand for ore concentration is actually a separation process. The first step is actually to crush the ore into small particles, and the mineral is then separated from the gangue, okay, by physical means. Okay, so gangue is actually the unwanted or insoluble materials that you didn't want. Okay, so it can be separated using a cyclonic wind. Okay, you can actually blow wind, okay, to separate the material by density. Okay, another thing is by isolating the froth. Froth is actually like a bubble, like a foam that forms from flotation methods. That normally mineral is treated with wetting agent to make it more attracted to the froth. Okay. The first method is known as gravity concentration. Okay, some ores are heavier than the waste. Okay, the ore, after you have ground it, okay, it will be shaken in the jolting box. It will be vibrated. Okay, or similar while wet. So you will see this a lot. I mean, like the treated ores after it had been pulverized or crushed, it will be like mobilized using a water, and then it goes into this jolting box where the materials will later on I think, sit on the bottom of the jolting box. Okay. The particles will separate into layers depending on the weight. The metal may be removed as a layer. Okay. So this also applies to another method, traditional method that you've seen a lot. I mean, that using not really a flat surface, but like a pan or something that you put the mixture inside, and you just like jolt it, and you just shake it or jolt it, and then you can actually find the materials that you want on the bottom of uh, the the jolting flat. Materials. Okay. Flotation is also another method. The fine particles of ore are shaken, okay, or swirled around in the large tank with a air blown in the flotation agent is added. Okay, the particles attach to the bubbles and the float of the surface where the froth form will be skimmed off. So in this method, basically, you have like a agitator, you have a wetting agent or flotation agent added. The same time, it will be bubble. So what happens is that the wetting agent and the bubbles will actually complex the metal, and you will see that the froth is being forming on the top of the layer. So this will be later on removed out. Okay, as the uh, interest material. So basically, this is a principle of flotation methods. You have a agitator where the air is later on pumped in. Okay, while stirring, the bubbles will be purged. Okay, air will be purged, and then the chemicals will be react. Okay, and you will see that the air bubbles will be like complex or attached with the ore, and then the ore will be skimmed off. Okay, using a motor-driven skimmer, and the materials will be collected. Next. Another method is actually by using magnetic separation. This is basically for materials that have magnetic properties. Okay, so some materials or some minerals may have a permanent magnet properties. For example, okay, ferromagnetics or ferric magnetics material. Okay, in the separation of ore that have magnetic properties, the ore is ground and passed over a rotating drum. Okay, so the rotating drum actually having a magnetic properties. Okay, it has like a coil wire, and then when you put a current on it, it becomes a magnet. Then the materials or the magnetics mineral will be attached or will be detached on the surface, leaving out the non-magnetic materials apart. The drum has a magnetic inside, which hold the magnetic ore particles as the waste fall outside the screen. Okay, the ore held on the drum can be released by scrap off, or sometimes if they didn't use permanent magnets, as I said, the most common one they just use a solenoid wire. Okay, when you put like current, it will become magnets, and when you stop the current, okay, it is no longer become magnets, and you can easily remove it out. So this is actually the principle of magnetic separation. Okay, the drum will rotate, and this drum actually equipped with magnets or magnetic properties. The ore will be put into the feed, and then during the mixing or during the rotation process, the ore can be easily extracted. It will attach to the drum. Okay. So, is there anything that you want to ask? Any questions so far regarding on ore concentration? Ada soalan? Anything? Ada tak ada? Okay. We are moving on to the next slide, which is on the metal extraction. Perhaps maybe for this one, we will go more detail. I think tomorrow. Okay. And for metal extraction, we can actually divide it into three major processes. The first one is actually known as pyrometallurgy. Second one, hydrometallurgy, and third one, electrometallurgy, or sometimes coupled with temperature, known as thermoelectrometallurgy. Okay. So by definition, pyrometallurgy, pyro, anything that you see with pyro, it means heat, heating. Okay. In pyrometallurgy, a furnace will be heated, okay, and used with the reducing agent such as coke, and a flux to produce a metal and slag waste. Okay, so most of this process in pyrometallurgy is that the ore will be burned in the furnace with the presence of oxygen, with the presence of charcoal, with the presence of coke, okay, to produce the molten metals. The second method is known as hydrometallurgy. So hydrometallurgy is known as one of the soft technique because it didn't require heating. In this case, in hydrometallurgy, you will use chemicals, okay, the chemicals that will leach, okay, the metals or dissolve the metals, okay, in a solvent, and then using electrolysis, it will be separated, or using precipitation techniques, it will separate the ores. And finally, you have thermoelectrometallurgy. So this method is more or less related with electrolysis method. Okay, the concept is actually using electrolytic cell. Okay, you will melt the ore. You will heat the ore. Okay, and then you put the electrodes inside the molten ore, and then when the electrode is connected into I think a cell or whatsoever, then it will actually isolate or refine the ore. Aluminium can be extracted from salts or mineral mixture by electrolysis. This is actually the electrolysis of bauxite, which you have learned during your high school. Okay, it uses a lot of electricity, making it an expensive process. Blister copper can be refined by electrolysis. Okay, so for this one, I guess it has a few consideration. Like for example, for pyrometallurgy, you have to remember that for this method, it will produce higher yield with the same time, slightly higher purity. Okay, but the cost is of course expensive because it involves heating. Then when you have anything that involve heating, the cost, operational costs, will be expensive. Hydrometallurgy is one of the cheapest method because it's just using chemicals. It can be run at ambient temperature, at a moderate temperature. But the disadvantages of hydrometallurgy, of course, the yield, percentage yield is less as compared to pyrometallurgy and electrometallurgy. Right. And finally, for electrometallurgy, okay, the purity of the metal is quite high. Purity is high, but the percent yield is not that high, just moderate. And then the cost, the operation cost for electrometallurgy is expensive. Okay, so all methods actually have its pro and cons. It depends on the budget and depends on the purity that you want. Then later on you will choose the specific metal extraction methods. Right. So I believe for pyrometallurgy and others, we are going to continue tomorrow. Okay. And forgot that tomorrow we have class around 8, right? So because tomorrow around 8, I have an appointment, okay, in the morning. So I'm not sure whether we can reschedule the time. Okay, if you guys agree, we can have our class tomorrow like around 8, not 8 a.m. but instead 8 p.m. Not sure whether you guys agree. If you guys are okay, we just proceed tomorrow. Those who are not free tomorrow 8 p.m., I will make a recording and I will post the recording later on in the YouTube. Okay? Right. So those who just joined slightly later, this is basically your group arrangement for presentation. I have divided you guys into 8 groups. Okay. So probably later at the end of this week or next week, I will start to give you videos related on different types of process, and the outcome for this one will be, of course, a video presentation, okay, by means of like PowerPoint, whatnot, and then finally a report or a written report on, of course, that covers the introduction, the literature review, experimental, the expected outcomes, and of course, the anything that you think you can suggest to improve the process, you can discuss, and finally the references. Okay, so before I adjourn the class, is there anything that you want to ask? What we have learned today? Anything or anything regarding on the presentation?
Assalamualaikum doktor. Doktor,
Wow.
untuk homework poster kan, boleh
Yep.
tak kalau doktor tangguh due hari Isnin?
ada apa-apa reason ke? Any specific reason? Nadira?
Sebab saya punya laptop ni saya nak kena hantar pergi servis kejap. Dia ada problem.
Kalau kata during the weekend boleh? Not Monday lah, during the weekend.
Pun boleh doktor, boleh.
Boleh Okay, so if that's the case, then I just extend it until the weekend lah. Nanti sekejap lagi saya ubah deadline dia dekat e-learning tu. Okay?
Doktor, thank you.
Welcome. Any other things that you want to ask regarding on lecture or regarding on the presentation? The presentation task. Yes, no? Right, so if no further question, then thank you very much for your kind attention. I know it's afternoon, you guys must be in hurry for lunch. Okay, I'm also going for lunch after this. Okay, we'll see you tomorrow, not 8 a.m. but 8 p.m. tomorrow. And of course, if you remember, you have your assignments that you need to submit within this week. So hopefully you guys doing it, and if you have any problem regarding all your assignments, just contact me directly. So again, thank you very much. We'll see you tomorrow and have a good lunch, everyone. Goodbye.